Hello friends, welcome to this video. In our earlier videos, we have learned about force and acceleration. So here in this video, we will learn about Newton's laws of motion. Okay, so Newton's laws of motion are also related to force and acceleration mainly. So there are three Newton's laws of motions: Newton's first law of motion, Newton's second law of motion, and the third law of motion. So in this video, to keep the video short, we shall discuss only Newton's first law of motion. So let us see what is Newton's first law of motion. So this is also known as the law of inertia. Okay. So what does it say? If a body is at rest, okay, body is at rest means no velocity, its velocity is equal to 0, and no unbalanced force acts on it. Okay, on the body there is no unbalanced force. Okay, it will remain at rest. Okay, so a body, if it is at rest and no unbalanced force, unbalanced force acts on it, so the body will remain at rest. So about unbalanced force, we learned in the one of the last videos, whose link I will give here. Please go to that video and check what is an unbalanced force. Okay, so the body will remain at rest. Now, for a moving body, okay, what if the body is moving? For a moving body, if no unbalanced force acts on it, it will continue to move at constant speed in a given direction. Okay, so now suppose a body is moving and there is no unbalanced force on the body. So what will, how will that body react? So that body will continue to move at constant speed in a given direction. Okay, so since there is no force, so the speed of the body cannot be changed. Okay, so and now a body will accelerate it only if an unbalanced force acts on it. Okay, so suppose a body is at rest. Okay, this is a body at rest, and then unbalanced force. Unbalanced force means this is a force, and if there is an equal and opposite force from the same from the opposite direction, equal and opposite force, so that the body will not move. Okay, but if there is no such force from the opposite direction, then the body will gain an acceleration. Okay, the body will accelerate if an unbalanced force acts on it. Okay, so what have we learned? A body at rest will remain at rest if no unbalanced force acts on it. A moving body will be moving with constant speed in a given direction if no unbalanced force acts on it. And a body will accelerate if an unbalanced force acts on it. Okay. So statement, what can be the statement? So a body will continue to remain at rest or uniform motion unless it is acted upon by an unbalanced force. Okay, so a body will maintain its state of rest or uniform motion. Okay, the body will continue with state of rest or uniform motion until and unless it is acted upon by an unbalanced force. The state of rest or motion of the body cannot be changed. Okay, if there is no force, a body remains unaccelerated. Okay, another way of defining the first law is a body remains unaccelerated if and only if the net force acting on it is 0. Okay, a body remains unaccelerated. Okay, it will not have any acceleration if the net force acting on it is equal to 0. That means if acceleration will be 0 if the net force acting on the body is equal to 0. Okay, so this is basically the first law of motion. But I hope you have understood the first law of motion from these points. But another important thing that comes into picture along with this first law of motion, that is the concept of inertia. Okay, what is inertia? So in the absence of an external force, okay, we have already learned a body at rest tends to remain at rest. Okay, then a body in uniform motion tends to continue its motion. Okay, we have already learned it. So what does inertia mean? So how would we define inertia? The inability of a body to change its state of rest or uniform motion is known as inertia. Okay. Suppose a body is either at rest or it is maintaining some uniform motion. So the body will tend to stay in its state of rest or uniform motion. Okay. It will just tend to stay in that motion. Okay. The body will not try to adapt to any change. The body will not try. Okay. And when will the body lose its inertia, or simply when will the body change its state of rest or uniform motion? When it will be acted upon by a force. Okay. If there is no force, okay, if there is no force, then the body will maintain its state of rest or uniform motion, and this is known as inertia. Okay. So inertia is simply the willingness of the body to maintain its current state of rest or uniform motion. So there are two types of inertia basically. So one is called inertia of rest, and the other one is called inertia of motion. So what is inertia of rest? So the willingness of the body to maintain its position of rest is known as inertia of rest. And what is inertia of motion? The willingness of the body uh, maintain its state of uniform motion is known as inertia of motion. So here you see an example. Here there is a glass, and on the top of the glass there is a cardboard, and there is a coin. Okay, suppose there is a coin. So now what this person is doing? This person has hit this uh, cardboard, and very fast. Okay, very fast. He has hit it with his finger. So what will happen? This cardboard will go away. It will move away, but this coin, it will fall inside the glass. So why the coin is falling inside the glass? Because the force is on the cardboard, not on the coin. Okay, since the coin is at rest, okay, in this position the coin is at rest. Okay, so the coin will try to maintain its position of rest, and therefore when the cardboard is moved by a large force from the finger, it will fall inside the glass. Okay. So similarly, another example you see here, suppose a person is inside a vehicle. Okay. So at rest, the person is standing straight. But when the vehicle just begin to accelerate, what will happen? The upper body of the person, it moves backward compared to the legs. Okay. So here what happens, the upper portion of the body of the person, so it remained at rest initially, so it will tend to remain at rest. Okay, but since the vehicle has just started moving, so this portion of the body will move backward, but the lower portion of the body, so which is in touch with the vehicle, or the floor of the vehicle, you can say, so that will tend to stay in its own position, okay, because it is in touch with the vehicle. So this is an example of this. So due to the inertia of rest, this portion moves backward, but due to since this part of the body is touching the floor of the vehicle, so it remains in its own position as before. Okay. So these are the examples of inertia of rest and inertia of motion. So one more example maybe I can give you. So sorry, just give me a second. Suppose a vehicle is moving, okay? Suppose the same vehicle is moving and it comes to a halt suddenly, okay? Suppose the vehicle was moving and suddenly it comes to a halt because maybe the driver put the brakes of the vehicle. So what will happen? What we observe that the upper portion of the upper body of this person would move forward or lean forward. Okay, but this lower portion of the lower portion of the body, which is in touch with the vehicle, that will come to rest immediately. But this upper portion of the body, which was initially moving due to the motion of the vehicle, so that would still continue to move along the direction of motion of the vehicle. So it would lean forward even when the brakes are applied. Okay, so that is an example of, actually that is an example of inertia of motion. Okay, so inertia of rest, the body tries to maintain its position of rest, and inertia of motion, the body tries to maintain its state of uniform motion. Okay, I hope these examples have been clear to you. Okay, so inertia and mass. Okay, so how are mass and inertia related? Okay, let us consider an example here. One is football you have, and another is that you have a tennis ball. Okay, so the football will resist any attempt to change its motion more effectively than the tennis ball. Okay, therefore the football has got larger inertia than the tennis ball. Why? Because the football is heavier than a tennis ball. Okay, football football is heavier than the tennis ball. So the football will try to resist any change in its state, okay, be it state of rest or state of uniform motion, as compared to the tennis ball. Okay, because the football is heavier than the tennis ball. Okay, the tennis ball being lighter, it will accept any change much easily, any change in its state of rest or motion easily. A heavier body has greater inertia than a lighter body. Okay, heavier body, the football has greater inertia. What is again inertia? Inertia is the inability of the body to change its state of rest or uniform motion. Okay, therefore the football will have greater inertia than the tennis. That means a heavier body will tend to change its state. Heavier body will tend to change its state of rest or motion more effectively than lighter body. Okay, then heavier body will tend to oppose. Sorry, I missed this word, oppose. A heavier body will tend to oppose changes in its state of rest or motion more effectively than a lighter body. Okay, because since the body is heavier, it has more mass, so it will not tend to change its state of rest or motion easily if we compare it to a tennis ball, a smaller or a lighter object like a tennis ball. Okay, so that means the inertia of this football is greater than the inertia of the tennis ball. Okay, inertia of football is greater than the inertia of tennis ball. Again, why? The football is heavier than the tennis ball. Okay, so mass is a measurement of inertia. Okay, so if we talk about inertia, or if we have to define inertia, so mass is an important parameter which defines inertia. Greater is the mass, greater is the inertia. Okay, so as we have seen in this example, for the football, the mass is greater, so greater will be the inertia. Why? Because the football will resist, or the football will oppose any change in its motion more effectively than the lighter body or the tennis ball. Okay, so the football will have greater inertia because of its greater mass. So friends, I hope you have understood these concepts of inertia and mass here. And earlier we have discussed the what are inertia, inertia of rest, and inertia of motion, and first law of motion. I hope you have found this video useful. So you can watch the video, and if you have any questions or comment, you can post in the comment section. And thank you very much for watching. Do like, share, and subscribe, and see you in the next video. Thank you very much.